Welcome back. We're in Chapter 23, Quiz A, Question 1. A professor at a large university believes that students take an average of 15 credit hours per term. A random sample of 24 students in her class of 250 students reported the following number of credit hours that they were taking. Take a minute, please, and enter this data in list 1 of your calculator. Okay, does this sample indicate that students are taking more credit hours than the professor believes? Test an appropriate hypotheses and state your conclusion. So let's take a look at our null and alternative hypotheses. Our null hypothesis is always a statement of no change or no difference. So that means our null hypothesis would be mu, the average, is 15 credit hours, no different than the professor reported. Our prompt, however, indicates that maybe in fact it's greater than that. Are they taking more credit hours? So our alternative hypotheses would be mu, the average number of credit hours, would be greater than 15 credit hours. Excellent. Now we have to check our conditions for inference. What are the conditions for inference for means? Well, let's take a look. So first, we have the randomization condition. Students from the class were randomly sampled. And in fact, you see that right here in the prompt, a random sample. All right. Next, the 10% condition. 24 is less than 10% of the 250 students. Excellent. And finally, the nearly normal condition. So in this condition, we want to draw a box plot in our calculator. We do this by going second y equals to our stat plot. Make sure we select a box plot with outliers. And then we hit zoom 9. And we should get a box plot that looks like this. And clearly we can say that this box plot is roughly symmetric with no outliers. And finally, we can say all the conditions have been met and that this distribution can be modeled by a student's t with 23 degrees of freedom. And the degrees of freedom is always sample minus 1. So we're going to use a one sample t-test for means. Well, what do we know? Well, we put our data in our calculator. So why don't we calculate our one variable statistics? How do we do that? Well, we go over to our stat menu, we arrow over to calculate, and we calculate one variable statistics. And when we do that, we should get something that looks like this. So now we know the sample of our mean, or our statistic, is 16.625. That is our sample mean. We also know that the standard deviation of my statistic, according to the calculator, is 2.222. But just a reminder, we need to take this value and divide it by the square root of n. Okay? So let's take a look at what we need to do over here. We know our sample size is 24. We know our sample mean is 16.625, and we know S is 2.222. We're going to use that information to calculate the standard error of our sample mean, which is S divided by the square root of n. So 2.222 divided by the square root of 24 is 0.45356, and just store this number in your calculator. Now, of course, we have to find our t value. Remember, proportions, we find our z value. Means, we find our t value. Same exact equation, though. In order to find t, it is statistic minus parameter over the standard deviation of the statistic. So what does that look like for t? Let's see. Okay, symbolically, that's what this would look like. Now we're going to plug in our information. We know our sample mean is 16.625. We know the mean of our parameter is 15. And just above, we've calculated the standard error of our sample mean. So when we plug it in, this is what we get. And finally, we come out with the t-value of 3.583. Now we know a t-value of 3.583 is unusual. So we expect a small p-value. And we're thinking, as we move along in this problem, that we're going to reject the null. Let's take a look at our curve. So here we have our curve, and the parameter, the mean of the parameter, is labeled as 15. Here is our sample mean, 16.625, and our t-score that would be associated with that sample mean is 3.583. And we're trying to calculate a p-value for this small area under the curve right here. So what are we going to do? We're going to go to our distribution menu, and we're going to arrow down to TCDF. TCDF. Okay? And when we do that, oy vey. Oh, I knew I shrunk it when I clicked it. There we go. Come on. Good. So we have a lower bound of 3.583. That would be this boundary right here. We have an upper bound of some very, very large number. I always use 99999. We know our degrees of freedom is always n minus 1, so the degrees of freedom here are 23. And we hit enter, and we get our p-value. And again, we know that this p-value is very, very, very small. And that p-value is actually roughly 0.00079. This is what it would look like in our calculator. 7.87 times 10 to the negative fourth. That is a very small p-value. And this is what it would look like using notation. The probability of t with 23 degrees of freedom being greater than 3.583 is equal to 7.87 times 10 to the negative 4, which is approximately 0.00079. So now we've done all the mechanics of our test. We've checked our conditions. We've written a null and alternative hypotheses. The last step is to write a conclusion in context. Again, we have a very small p-value, and we need to talk about that. Whoop, okay, there we go. The p-value is 0.0079. That's well below an alpha level of 5%. So we reject the null hypotheses, and there is strong evidence to suggest the professor's students are taking more than 15 credit hours on average. This would be our conclusion. Always compare the p-value to the alpha level. Always reject the null or fail to reject the null. And again, always have context of the problem. So there is strong evidence to suggest the professor's students are taking more than 15 credit hours on average. Now let's use our calculator to check the mechanics of our test. If we go to our stat menu, arrow over to test, this is just simply called the t-test on your computer, or in your calculator, I should say. Here we go. It's called the t-test. Our input is in our data list, okay? So our parameter is 15 credit hours. Our data is located in list 1. And our null hypothesis is greater than 15 credit hours. And we're now just going to hit calculate. And what we should get should confirm the mechanics that we have just completed. So let's take a look. Okay, so the t-score according to the calculator is 3.582, which is very, very close to our t-score. The p-value according to the calculator is 7.896 times 10 to the negative fourth, which again is extremely close to what we got. Here you see our sample mean is 16.625. Our value for S was 2.222, and N is 24. So in fact, the t-test confirms all of our findings. And that's how we would check our work in our calculator. Excellent. Tune in again next time. Again, Chapter 23, Quiz A, Prompt 1.